Welcome to section 1.6. We're going to be talking about parent functions. And these are the functions that we're going to be working with. And these are the basis for all of the transformations we're going to be working with our functions. So our first is a linear function. You can kind of read through all these. We've worked with linear functions quite a bit. Linear functions, the graph is a line. So what we're going to do is we're going to write a linear function f for which f of 1 equals 3 and f of 4 equals 0. So the first thing we're going to do is we're going to transform the 2 points. We're going to write them in a more familiar form. Remember, inside is our x, outside is our y. So our 2 points, so we have the point 1, 3, and the point 4, 0. So now we're going to find the slope of that line. Slope, m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. 0 minus 3, 4 minus 1. So our slope is going to be negative 3 over 3. The slope is negative 1. All right. And now we can find the equation. Y minus y sub 1 equals m x minus x sub 1. We can use either 1, 3, or 4, 0. I'm going to use 4, 0 because I feel like it. So it's going to be y minus 0 equals the slope, which is negative 1, x minus 4. So y minus 0 is y. Distribute the negative 1, you get negative x plus 4. And there is our equation. We can graph that equation by going to 0, 4. And we're going to go down 1 over 1 each time. And then we'll draw our line through those points. And there is our linear function. Now, identifying the domain, range, and intercepts. Our domain, it's all real numbers. So in interval notation, we're going from negative infinity to positive infinity. Our range is all real numbers as well. So we're going from negative infinity to positive infinity for our outputs. Our x-intercept, we're given our x-intercept as one of our points. So our that's a y-intercept. But our x-intercept is at 4, 0. And you can see our y-intercept is also going to be at a 4. So our y-intercept is at 0, 4. Now, is the function increasing, decreasing, or constant? Now, it's decreasing the entire time. So it's decreasing. And remember, when we're talking about our decreasing, we're saying which values for x is the graph going down. And it's decreasing on the interval from negative infinity to positive infinity. The entire length of that line, it's decreasing the entire time. That's a linear function. Pretty straightforward. We've worked with those for years. Other linear functions where f of x equals a constant. Now, f of x equals c, that's the same as y equals, let's say, 2. I'm just giving it a number to make it easier to graph. So that is a horizontal line. Now, the domain of that horizontal line is all real numbers. So negative infinity to infinity. The range, our output. Our only output in this case is 2. If we're thinking generically, it would just be c with brackets. For this example, the 2 in brackets. The intercepts. The x-intercept, there is none. This one never crosses the x-axis. And the y-intercept for this example specifically is at 0, 2, or 0, whatever c is. Is it even or odd? This has y-axis symmetry, meaning it's an even function. Increasing, decreasing. This one is actually constant. And it's constant for its entire length, from negative infinity to positive infinity. So that's a horizontal line, where it's a constant function. Now we have the identity function. This is just y equals x. This is really the parent function for all of these linear functions where y equals x. So now our domain stays the same, negative infinity to positive infinity. Range, all real numbers, so negative infinity to positive infinity. Our intercepts, the x-intercept is at 0, 0, and that's the same place as the y-intercept because that's the origin, 0, 0. Now this function has origin symmetry, meaning it's an odd function. And this graph, for increasing, decreasing, it increases the entire length, negative infinity to infinity. Next, we have an absolute value function. Y equals the absolute value of x. Absolute value functions look like a V. Absolute value functions look like a V-shaped graph. So our domain, all real numbers, negative infinity to infinity. Our range, we never go below 0. So starting at 0 with a bracket to positive infinity. Remember, we go from smaller to larger. Our intercepts, the x-intercept and the y-intercept are at the same spot. They're both at the origin, 0, 0. Looking at the symmetry of this, it has y-axis symmetry. If you reflect along that y-axis, if you fold along that y-axis, everything matches up, so it's an even function. Increasing and decreasing. Now, it decreases. If we're going from left to right, it decreases along that interval from negative infinity to 0. We're going to put a parentheses at the 0 because at 0, it starts to increase there as well. So the increase is from 0 to positive infinity. And those are our linear functions. The absolute value is a little bit different because it's a V, but both sides of the V are straight. Some nonlinear functions, a square root function. So y equals the square root of x. So we can make a quick table of values. 0, 1, 2, 1, and we'll make that a 4 and a 9. That way we get whole number outputs of 0, 1, 2, and 3. Those are just the square roots of those inputs. So our square root function has that shape to it. Now the domain, because we can't take the square root of a negative, 0 to infinity. We're going to use a bracket because we can take the square root of 0 and a parentheses at infinity. Our range, our output of 0 to infinity. Our intercepts, the x-intercept and the y-intercept are at the same spot of 0, 0. For symmetry, there is none. There is no symmetry here. And for even or odd, it's neither. Remember, even has y-axis symmetry, odd has origin symmetry. Since there's no symmetry, it's neither even or odd. And now this increases, and it starts at, that should be a bracket, 0 to infinity. The squaring function or quadratic function, y equals x squared. We can make a quick table. -2, -1, 0, 1, and 2. So that gives us a 4, a 1, a 0, a 1, and a 4. Those are our squares. 0, 0, 1, 1, 2, 4. This is our quadratic, the parabola. So our domain, we can use any input we want to, negative infinity to positive infinity, all real numbers. Our range, our outputs, we start at 0 and we go towards positive infinity. Once again, our x and y intercepts are the same. They're both at the origin of 0, 0. if you look at the symmetry first, it has y-axis symmetry, meaning it's an even function. And for increasing and decreasing, if we go from left to right, it's decreasing along that interval for x from negative infinity to 0. We're going to use a parentheses at 0 because at 0 it starts increasing as well. And it starts increasing from 0 all the way to the x value of positive infinity. Keep in mind that interval for increase and decreasing, we're looking at the x values. We're looking at the x values where the graph goes up and the x values where the graph goes down. Let's look at a few more. A cubic function. A cubic function. Now, a cubic function, y equals x cubed, we can make a quick table. -2, -1, 0, 1, and 2. -2 cubed is -8. -1 cubed is -1. 0 cubed is 0. 1 cubed is 1, and 2 cubed is 8. So the graph is going to look like this. It's going to go up, turn, and then back up again. That's the graph of a cubic function. Domain, all real numbers, so negative infinity to infinity. Range, same, all real numbers, negative infinity to infinity. The x and y intercepts are at the origin at 0, 0. Now the symmetry is origin. This has origin symmetry, meaning it's an odd function. And for increasing and decreasing, as we go from left to right, this increases the entire time. It increases from negative infinity to positive infinity. And that is a cubic function. And next we have a reciprocal function. Y equals 1 over x. Now, because we're dividing by x, x cannot equal 0. We cannot divide by 0. So when x is -2, -1, I'm actually going to put a -1/2 here. Skipping 0 to +1/2, +1, +2. So that gives us a -1/2, a -1, and then a -2. 1 divided by 1/2 is +2, then a 1, and then a 1/2. So we're at -2, we're at -1/2, -1, -1, -1/2, -2. And here's our other values. So what happens is you can keep looking at this graph. You're never going to get to y equals 0, and x can never equal 0. So what the graph looks like, it looks like this. I'm going to clean this up a little bit just so we see that we don't cross that y-axis. So what we have here is we have asymptotes. Those are lines we get very close to but never intersect. So we have an asymptote at x equals 0, and we have an asymptote at y equals 0. This is what's called a hyperbola. So our domain, we can use anything but 0. So we're going from negative infinity to 0 with a parentheses, and then the union of 0 to infinity. Remember, that's all real numbers except x equals 0. Same thing with the range. We can never get an output of 0. So we're going from negative infinity to 0 and the union of 0 to infinity. The intercepts. This never crosses the x-axis and never crosses the y-axis. So there are no intercepts for this graph. For symmetry, this has origin symmetry. So it has origin symmetry, meaning it's an odd function. And as we're going from left to right, you can see from left to right, the graph is going down from negative infinity towards 0. So it's decreasing from negative infinity to 0. We're using a parentheses because we never actually get to x equals 0. But as we go to the other side, it's still decreasing over there. So it's decreasing once again from 0 to infinity with a parentheses, because once we never get to x equals 0. Those are our beginning of our parent functions. We'll talk about transformations later in the chapter, and we'll talk about some other types of functions that we'll be graphing as well in the next part. Thank you.